Hi, I am Shoaib Raza. Let's discuss about immutable maps and key value storage with functional properties. Immutable maps offers a powerful approach to key value storage in functional programming. They provide unchangeable data structures that maintain referential transparency and enable efficient manipulation of complex data. Data structures that cannot be modified after creation. They store key value pairs persistently. Next, functional programming concept. These maps aligns with functional programming principles, ensuring data integrity and predictability in application. Next, efficient operations. Immutable maps supports efficient lookup, insertion, and deletion operations without altering the original structure. Let's see an example for it. Let's take a linked list. Here we are creating a linked list. We are inserting some elements in it. But we want 7 also in this linked list. So here we need to add 7. But in immutable maps, you cannot change the original one. You cannot modify the original one. So now we need to create another linked list using the previous version so that we can add 7 into the linked list. This is the previous version, but we are creating a new map so that here we are adding, by creating new map, we are adding the 7. Next, let's see persistent data structure. Creation. A new immutable map is created with initial key values pairs. The structure remains constant. Next, modification. When changes are needed, a new map is created. It shares unmodified parts with the original one. Efficiency. Sharing unchanged elements between versions ensure memory efficiency and quick copy. Here we can understand that there are multiple threads, but they will not be combined by using immutable data structures. Next, predictability. Unchanging nature of immutable maps ensures consistent behavior. This simplifies debugging and testing process. Like we can predict the code, we can predict the upcoming results. Next, caching. Immutable structures can be safely cached. Their constant state allows for efficient memory techniques. Next, immutable map operations. Mainly, we can do 3 operations in immutable maps: get, put, remove. Get. Retrieve a value associated with a key. The operation is non-destructive and fast. Next, put. Create a new map with an added or updated key value pair. The original remains unchanged. You can add or you can update an key value, but the original one remains unchanged, and you are going to create a new map for it. Next, remove. Generates a new map with a specific key value pair. The initial map is unaffected. You are going to create a new map, but you are going to delete a specific key value pair that you do not want in the list. Next, let's compare the performance considerations of immutable map and mutable map. Let's see. We are taking here 4 operations: lookup, insert, delete, memory usage. In lookup, immutable map is order of login, mutable map is order of 1. In insert, it is immutable map order of login, mutable map order of 1. In delete operation, immutable maps are order of login and mutable maps are order of 1. In memory usage, immutable maps are higher and mutable maps are lower because we are going to create always a new map for insertion or deletion so that it will offers more memory usage than mutable maps. Next, let's see the real world applications of immutable maps. Version control system. Immutable maps efficiently store and manage different versions of files and directories. Functional programming languages. Languages like Scala utilizes immutable maps as core data structure. Next, state management in React. Redux and other state management libraries leverage immutability for predictable state updates. Next, financial systems. Immutable data structure ensure audit trails and data integrity in financial transactions. These are mainly four applications, but immutable maps are widely used in nowadays. Next, comparison to mutable dictionaries. Immutable maps, unchangeable, thread safe, and ideal for functional programming. They create a new instance for updates. Mutable dictionaries modify in place, faster for frequent updates, but prone to side effects and concurrence issue. Mutable maps are less memory usage than immutable maps, and they are fast. But there is a chance of side effects in mutable maps. Now we can see the use cases of both. Choose based on your program's need. Immutable for safety, mutable for performs critical scenarios. Key characteristics and examples for immutable maps. There are four main key characteristics: immutability, structural sharing, persistence, key value storage. Immutability. Once created, the map structures and content cannot be changed. Structural sharing. Efficient memory usage through shared data between different versions of the map. Persistence. All versions of the map remain accessible, allowing for travel debugging. Key value storage. Data is stored and retrieved using unique keys, enable quick lookups. Next, functional properties of immutable maps. Here we are going to explain three functional properties of immutable maps. First one, referential transparency. Functions using immutable maps always produce the same output for the given inputs. It always produces the same output for the given inputs. Next, side effect free. Operation on immutable maps do not affect the original data, ensuring predictable behavior. Here, in immutable maps, we are going to update the or insert or delete an map using the new version so that it is side effect free and we can predict the behavior. Composability. Immutable map operations can be easily combined to create complex transformations. Next, immutable maps safeguarding data integrity. Immutable maps are a powerful data structure that provide functional properties, ensuring data integrity and enabling efficient concurrent processing of a key value pair. Discover the algorithm behind this innovative approach to data storage and management. Let's see the immutable map algorithm. Mainly, it follows three steps: data insertion, data retrieval, concurrency control. Data insertion. New key value pairs are added to the map, creating a new version without modifying the original. Same process is followed for deletion. In the place of insertion, we are going to deletion. Next, data retrieval. Retrieving value is efficient as the map's internal structure allows for quick loops. Next, concurrency control. Immutable maps enable concurrent access and modification without the need for the complex synchronization mechanisms. Here we can observe Java code for immutable maps. Import java.util.map. We are inheriting map from java.util.package. Public class immutable map. We are creating an class with the name of immutable map. Next, creating an immutable map. We are going to create an immutable map on the name of a person, on the name as a person. Next, here we are using the string keyword map of. Map of is used to create a map. Here we are giving some inputs as name, hero, city, London, occupation, engineer. And creating an immutable map is completed. Now we need to print it. System out println will print the created immutable map of the person. Next, now we need to update the immutable map, but we know that in immutable maps we cannot modify the previous version. So we are going to create a new immutable map and we are going to update it using the previous key values. Let's see. Here updated person shows that we are using the previous key values and going to update it. Map of, we are going to create another immutable map using the previous key values as name, city, occupation, and here age 18. This shows we are going to add another keyword for it. Now we have created another immutable map using the previous key values and updating it. Now system out println of updated map will print the updated version of the immutable map. Next, key takeaways: data safety, performance, concurrency, and testability. Data safety. Immutable maps ensure data integrity by preventing accidental modification, making them ideal for mission critical applications. Performance. The efficient internal structure and caching capabilities of immutable maps contribute to improve performance and scalability. Concurrency. Immutable maps enable seamless concurrent access and modification, simplifying the development of concurrent systems. Testability. The predictable and deterministic behavior of immutable maps make them easier to test and debug. Thank you.